Welcome. In this lecture, what we're going to talk about is how you would actually verify that something's a ring. Like you're given a set and you're given two binary operations, and then somebody says, "Is this a ring?" And so, well, I don't know. What do I actually need to do? I'm not going to go through all the steps of this in the circumstance of the real numbers. A lot of them are just properties that you could go back into real analysis or something like this to know, like, where these properties come from and so on. But the fact that they're there, you need to check. And in many cases, you do actually need to check that the properties are satisfied. And we'll go through a little bit of that in other lectures. Okay, but what would you actually need to check? Okay, so to prove or to verify that our, so my set is R and my binary operations are addition and multiplication as we're used to them, is a ring. Then you need to verify. So there's kind of two classes of things that you need to do. So the first one is that we actually have, right, this is like the correct kind of object. This is what I was saying. You don't talk about, if I'm talking about units, I'm not talking about a ring, I'm talking about elements of a ring, right? And you need to make sure that you're actually talking about the correct kind of object is the first thing when you're talking about whether something satisfies the definition, okay? So in this case, what is a correct kind of object? So what would we need to verify there? So correct kind of object. Okay, we would need, so R is a set. And we have that R is closed under addition and multiplication. So it needs to be closed under both addition and multiplication. Right? So what does that mean? Okay, so what does it mean to be closed under addition? So being closed under addition, right? So what does this mean? This means when I add two real numbers, I get a real number. Adding two real numbers yields a real number. Like the output is a real number. Okay, and then you could guess, so for under multiplication, now it would be, multiplying instead of adding. Okay, but you need to know that if your inputs are real, then your outputs are real. Okay, so that's kind of what this closure means here. And I usually call this is kind of like the hidden part of the checklist, because most people forget to do this, okay? When I say this is a checklist definition, this is like, it is part of the checklist, but it's really making sure that you have the correct kind of object. It's kind of like a first step. So this is kind of like your hidden steps in your checklist. Okay, and then once you've established it's the correct kind of object, now you have the real list of things. So what is the real list of things? Okay, so we need that each of the following properties hold. So we need it's the correct kind of object, and we need that each of the following properties hold. Okay, so we're going to have the commutative law of addition. We have the associative law of addition. We have the existence of the additive identity 0. We have the existence of additive inverses. And the associative law of multiplication. And the existence of the multiplicative identity 1. And then we have the distributive laws. Okay, so if I wanted to verify, somebody gives me a set and they give me 2 binary operations, then I have a list of things that I need to do to verify that this is actually a ring. I first need to make sure I'm the correct kind of object. So I need to be a set, and I need to be closed under addition and multiplication. That's part of the binary operations being well-defined functions. And then I also have this entire list of properties that one actually has to go through and check. This is a ring definition, is kind of a large, unwieldy definition, but you can do it. It's just I always tell students, when you have to verify that something is a ring or something like this, which is like a long list of things. Put on some nice music, or if you can, so some people can like watch some junk thing that they wanted to watch and not feel guilty like they were wasting time watching it. Some people can put that in the background while verifying properties. Some can, some can't. Even with research mathematicians, some can listen to music while working, some can't. Some can watch things in the background while working, others can't. So it really depends on who you are. But there's, find a nice environment, hang out with your friends, and sit down and prove the properties. Don't try to do it in like cold, dark isolation. That would just be torture. But it's good to kind of go through these things at least once so that you understand what it means, really, to prove that something satisfies something. Okay, so I hope that made a little sense and was helpful, and I will see you in the next lecture.